thank you for coming. I have been given a great honor to open technical part of your Ukrainian conference. I came, as Andrei says, from Croatia. I'm freelance consultant in IT infrastructure business, and I live from other people's computers for last 28 years. So I'm a little bit old in IT business, but that means that I have some experience. Today, I will speak things that every one of you knows, but somehow frequently forget. Maybe it will be a little bit disappointing for some of you, which is using all this stuff from day-to-day business, but unfortunately, I have a great example of the people which forgot how the computers work. And unfortunately, there is no magic. It is like in a real life. You have to find the right balance between salty and unsalty food. Everything which is extreme on other side is easy, but it is not good, unfortunately. So I will talk about CPU, memory, disk, and the network. I will be concerning server systems inside standard business environment and how to get most of it. And what are the things which are lying a little bit covered in documentation which could not be seen easily when you are configuring your system. So, few words about virtualization. It is a nice, great thing, but there is nothing magic inside. It is only sophisticated task scheduling system that few things could virtually work in parallel on the same hardware. There is no emulation. When one core is working in one virtual machine, it is working only that. If it needs to work something else, it's got to stop this job. So, all this stuff are really great, but like everything in life, there are some pro effects which is happening in reality. So, by virtualization, because of easiness, we are increasing number of instances of operating system, especially with new licensing models where you license physical box and you could run virtual machines whenever you want. Then you are increasing services because you can. And that all gives first higher complexity of a system, and the second, because of lots of pieces and details, we forget the basics, how computers are really work. These are the machines made by men, which are pretty stupid, unfortunately. If you look, for example, CPU, it is machine that could only sum two numbers. Subtract two numbers is done in way around with the summing of complement number. And that's all that CPU could do, except move some data here and there. So, I don't know, but I have an experience. And if you want to achieve good results in deploying performance of services, and the service is a king in IT, user experience is a king. And if you could achieve good result, you got to have knowledge about basics on which everything stands. Everything I talk, I will go through Microsoft Hyper-V, but it is true for anything you work with servers. It doesn't matter. So, first of all, I will discuss CPUs. Today, there is a huge number of available CPUs and systems from Intel. First, how many cores are packed together? How many CPUs are packed on one socket? The number today is going from 2 to 15 cores in Intel-based servers. It is a huge difference. Now, second part that we got to think about is working frequency. Usually, if you have more core, you have lower frequency. And from experience, you got to find a right balance among them. Because in standard business environment, in standard business services like business applications, databases, email systems, SharePoint, or stuff like that, it is not easy to parallelize things. And usually, more frequency means faster system. And if you add more cores, these cores could not have enough work to be loaded. So you got to carefully choose your CPU to achieve the goal that you have to achieve. Sometimes you need to have great density of virtual machines. For example, you are some kind of service provider or virtual machine provider, and you provide great number of machines, but performance of the machines are not important. But if you are an engineer in some company which needs performance, for example, on accounting system, frequency is everything that is count. And 3 gigahertz CPU will work 50% faster than 2 gigahertz CPU, especially in business applications, because you cannot parallelize, for example, process of giving goods on a stock and printing a bill. Things are connected together and needs to wait to be done. After that, there is a good marketing hype on turbo frequency. Today's server CPUs could go up to 4 gigahertz in turbo mode, but on one conditions: how many cores? Unfortunately, in real life, in a server systems, you could forget about turbo frequency. You could not achieve it because 2 or 3 cores more will work something, and CPU power dissipation will be too high to achieve this higher frequency. Then, in the last 5 years, we completely changed server architecture. Now, even small servers are NUMA, non-uniform memory access servers. What does it mean? Do you have a clue? It means that you glue together 2 servers on one motherboard and one input-output set of devices. So, it is important how much QPI speed is. This is a speed of communication between 2 or more CPUs inside systems. This is bus dedicated to communicate among sockets. And this bus is slower than a memory bus. Today, the fastest is 8 GTS. This means gigatransactions per second. And since it is 46 byte wide, it gets about 32 gigabytes per second of throughput among CPUs. I will discuss this a little bit more in memory. Now, number of memory channels. Depending on CPU, 2, 3, 4. What does it mean? 4 channels are double fast than 2 channels. Speed of memory, huge difference. Lower the frequency or the speed, lower power consumption. But if you need the performance, not the right way to go. Memory bandwidth. when you're choosing CPU on the same server, you could have from 25 to 85 gigabytes per second. Just you need to know what are you doing. And of course, in a huge systems, power is important stuff. But with the power, you could go a little bit relaxing than before. Because modern servers and CPU, if they are not working, could go to really low power mode, and you won't lose anything switching back to high power and low power. There is no significant performance degradation in a measurement. So if servers are not working, they won't consume lots of power. So just relax and it will be automatically done. So now, when we discussed physical CPUs, we got to speak a little bit about virtual CPUs and what to do. First question is, how many virtual CPUs can we put on physical CPU? And unfortunately, the only correct answer is you need to measure performance of virtual machines. After that, you will know. In some cases, at my customers, there is a situation when there is 16 virtual CPUs working on some application servers, and it is enough. And on the other hand, for example, if we have a virtual database server, one-by-one mapping is not enough. So you got to be very careful what are you doing. The next major thing is how many virtual CPUs to assign to virtual machine. This is something which you could kill your system. I have here a picture with 2 sockets, 2 core CPUs. How you could kill that system? Create one virtual machine with 8 CPUs, which is possible during the software. And the better way how to kill it, create two these virtual machines. What is happening? When you have multiprocessor virtual machine, let's say 8 CPUs, all 8 CPUs should work on physical CPU at the same time. So what is happening? Your virtual machines start to do some work. Everything else should be stopped. Then we need to switch content to other virtual machine, which is very painful operation. Why? Because we need to transfer all CPU register data to the memory. Each cycle to memory is 6 CPU clocks. And after that we need to load register from next virtual machine. So, my advice to you is, at least leave 1 core for host operating system, for virtualization and stuff like that. So, if it is not NUMA system, don't go with more than 7 CPUs in one virtual machine. If it is NUMA system, this is other discussion. But at that case, don't go with more than 4 if you not allow NUMA inside virtual machines. So now, how it looks in a real life. So, I'm connected now to my lab, which is basically 2 workstations with a little more disks, SATA disks, normal disks, nothing fast. And I have 2 Intel Xeon CPUs, each one is capable. I have 8 cores in 2 sockets with 16 threads because hyper-threading is enabled. It is not look good if I show you like this. Logical CPUs. So, if I not allow NUMA inside virtual machines, I shouldn't go on that system with more than 4 CPUs from my experience. I could configure it more, but it won't work faster. This is important. It won't work faster. Now, about NUMA inside virtual machines, first thing is Hyper-V settings. And this is, I don't have a decent mouse pad, sorry. So, will I allow NUMA inside virtual machines or not? It depends on us. My advice in real production is no, if you really don't need it. Because if you need power for more than one physical CPU, then probably you have a budget to buy another server. But if you allow it, okay, you got to know what are you doing. So then you got to go to any virtual machine in settings of virtual machines and configure it as it should be configured. How many sockets, how many nodes, everything you need to configure, of course, when virtual machine is switched off. So, now we are going a little bit further to memory story. Here is a pretty easy story. How many memory channels CPU have? What is the working frequency of a memory and how many modules could be connected per channel? And this is a craziness. You put only one DIMM in a server, power it on, no error, nothing, but server could work 4 or 5 times slower than it should. Because CPU needs only one memory module can be run. If you have 4-channel CPU, you need at least 4 modules. But after that, when you are putting more modules per channel, then you're losing a frequency. It is well documented somewhere in the middle of the server manuals, and I will use today to show you only one Fujitsu document, but it doesn't matter, it is Intel architecture. So, how today 2-socket CPU is working is written here. 4 sockets is the same thing, but you have lots of more interconnections. What is the trouble with NUMA? You see, if CPU 1 want to access CPU 2 memory, it should run only on 16 gigabytes per second instead of 50 gigabytes per second, which is optimum for this CPU. That's why I told you, if you really don't need, don't use NUMA. Other way is, when you are using NUMA, you need to have NUMA-aware services. For example, Microsoft SQL knows exactly which CPU have which memory addresses, and he will not cross-address memory and stuff like that. But if you use something locally developed, probably you will have significantly lower performance of your application than when you disable NUMA. So, story, how many DIMMs? Typically 3 per channel today in a 2-socket configuration. In a 4-socket configuration, sometimes up to 6 DIMMs. And there is complex table because memory frequency, it will vary from 800 to 1800 megahertz. So, if we go a little bit down, in this document, these are the configurations and achievable speeds of memory. So I have one better here. This is a little bit what type of memory you will use, at what number of DIMMs, but sum above everything is written in that table. If you want to use 256 gigabytes, depending on your configuration on a two-socket server and number of modules and utilized channels, your speed could vary without power savings between two speeds. But if you are going more than 512 gigabytes, and today two-socket servers could operate 1.5 terabyte of memory, but your speed will go down to 1000 megahertz. So there is a trade between high performance memory and high quantity of memory. From my experience and measurements on my customer base, rising speed of memory, rising performance of a system linearly, which means if you have double the speed of memory, you double the performance of the system. No but. So, it is usually much better to have less memory on higher frequency, and if it is not enough, build another server, physical. And it is cheap, because after you go over 256 gigabytes, pricing of a modules are extremely high, so it is not so much money to add to buy a second server. Today in virtualization, you could move a load easily and dynamically on flight, so it shouldn't be a problem. And especially if you go today in the afternoon to Andri's presentation about management of complex system, which is with virtual Microsoft System Center family, it is a really simplicity to move machines, load, deploy it, power it on, off dynamically, all stuff that is necessary. So, for now, at this particular moment, you could run 256 gigahertz on 1.8 gigahertz frequency, or 512 at 1.6. These are the 2 points that you could consider about. Every other memory configuration is not okay. If you use fast, lower memory, you don't utilize CPU performance. So, when dealer comes to you and want to sell you a server, you got to be very careful in checking configuration. How many modules, on what frequency, what type of CPU, and all the stuff like that. It is pretty complex. For example, it is a similar like buying a car. You have 3 models, same model with the 3 equipment levels, but after that you have a list. Ding, 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 but 6-speed is, you got to buy a radio with a Bluetooth because it is not okay, so be careful. Now, after a story of a memory, we have one other important stuff, which is use dynamic memory or no. Memory overcommitting, there is a lot of terms for that. What is dynamic memory? It is swapping, which means I emulate memory with the disk files. Since I'm old guy, maybe, I'm taking a significant amount of money from my customers to stop this process of swapping and tune systems not to swap. Why? Because, as you mentioned, top memory speed is 80 gigabytes per second. And today, with the SAS3 interface, the fastest hard drive to run about 1.2 gigabytes per second. So, disk is 50 times slower than memory. If you could accept it, go with dynamic memory. But if you need performance, avoid it. And the truth, like always, have two sides. So, dynamic memory is a nice tool for optimizing system. So, configure machine, for example, application server with 8 gigs of memory, and give him dynamic memory up to 12 gigabytes. Leave it in production for a month, monitor it. If it stays inside this 8 gigabytes, it is okay. And if you have some accident situation, for example, some extra load for data, you could use dynamic memory once. After use it, and if you see that you need it, you got to give it a more physical memory. You could see difference between virtual machines that are using dynamic memory and not when you are accessing these machines via remote desktop protocol. If you are accessing machine without virtual memory, your desktop will be as soon as possible here. If you use dynamic memory, you got to wait 10, 15, 20 seconds. It is noticeable difference. So be very careful with dynamic memory. After memory, the slowest component. The only component that keeps information without electrical power. It is a hard disk. Now, these days, we have basically two types of disk. We have good old mechanical disks, and we have solid-state drives. So, people forget how mechanical disk is looked and how it operates. Mechanical disk have heads which got to move around. And that's the greatest issue with the mechanical drive. So, from my collection of drives, now I will choose one mechanical drive. It is notebook drive 5.2 or 4K, cheap one to put lots of them in workstation. So for testing purposes, it works okay. It has, when it comes to GAM, some 100 megabytes per second in sustained one read. And what the people do? Put two or more jobs together, put two or more virtual hard drives which they expect to work together. What will be happened with the drive if it says, let's start with the 4 virtual machines on a single physical drive? What is the performance? Could you sum all performance on all machines? You make wind viper and heads are going left and right, but there is no read or write effort. And now, there are some wise sales guy who says, but our storage couldn't compensate. We could make a RAID of 100 of these drives. Yes, but unfortunately, in a one RAID array, all drives are synchronized. And if you take 10 of these disks for a single job, they will be 10 times faster. But on 4 jobs, you will have this 10 times faster, because all these drives in array, mechanical drives, should move their head synchronously. That's why SSD drives are much, much more better and today are not expensive as they were before. So now, just to show you, we will take one notebook solid-state drive. It is Intel 530, I believe. So, it is faster, as you could see, but this is not the major performance characteristic. The major performance characteristic is this. If I now zoom speeds around, I still have 400 megabytes per second, which is divided to my 4 virtual machines, which is perfect. Of course, solid-state drives have some problems. First of all, cheap models are not reliable because they have limited number of writing cycles. Of course, there is a server models which have almost unlimited writing cycles. And the other bad stuff about solid-state drive is that in some Western countries, example is United Kingdom, they are not evidence at the court of law. The reason why they are not evidence lies in the fact that you need to have algorithm to read and write data, and you could cheat. Comparing to mechanical drives, when you have pieces of English word for željezo, steel, not steel, but, and you could take plates from one drive and give it to other vendor and read your data out. So, be extremely careful when you are designing and configuring your disk subsystem. You need a lot of drives to utilize huge performance of Xeon, Intel Xeon CPUs. From my experience, good starting minimum is 10 physical drives per each CPU Xenon socket. If you have less than that and you are not in rendering business or some meteorological high-performance calculations, you have too many CPUs, sell CPUs, buy yourself hard drives. As more as possible. Now we will have another discussion about DAS or SAN, direct access storage, which means storage which are connected to only single server, or shared or storage area network where you could connect and share physical drives to computers. It's my opinion and experience, it is time to start avoid storage area networks as much as you can. If you have it, you could utilize it always in a way that it could be DAS. Why I'm talking about that? Because of few facts. Storage area networks are usually connected with fiber channel interface, which is all standard and it is really slow. It is 8 gigabits per second, not gigabytes, which means 800 megabytes per second. And single solid-state locally attached server drive on a SAS interface will operate 1 gigabyte per second. They are very expensive, storage area networks, and you could get 5 or even 6 times more physical drives or spindles, which you could divide it into the servers. And now we have server applications which knows how to give us redundancy without shared storage. Exchange is a good example because Exchange do not support shared storage anymore. There is no need for it. And if we are speaking about SAS interface, each SAS controller could operate today, and the new standard, about 9.6 gigabytes per second. So it is cheaper and faster, and you have redundancy, because storage area network is usually, in smaller systems, single point of failure. And replication of storage is something which is extremely expensive. And you don't want to take your money on that. And now, standard discussion about should we use RAID 0, RAID 1, RAID 5, RAID 6, depending for what. If we have high-level transaction database, of course that we will go only with RAID 10. If we have backup server or file sharing server, which will write for 10% of the time, and most of the time will be only reading the data, we will go to RAID 5, and of course RAID 6. If we use drives, physical drives that are bigger than gigabyte, if we use RAID 5, there is mathematical possibility that during rebuild of the failed drive, second drive will fail. So if you are using a physical drives bigger than gigabyte, and you usually do for file sharing and backup and stuff like that, use RAID 6 to be on a safe side. You will lose only one drive more, but it is acceptable for the risks that we are working on. And now, the thing that you shouldn't worry about. So now, I show you how this solid-state drive work on a physical machine. So it is, let us see, some 450 megabytes per second. Now, we will do it and check this drive to see how good Hyper-V is or how bad Hyper-V is. But where it is? Small resolution, so I miss some icons, but it will work. So this is animation. There is a latency from Kiev to Zagreb, so you see this is standard. So I have only one disk drive. This is this VHD on this SSD, which is on IDE interface, not on SCSI, which is a little bit faster, but if you go so the same drive, same environment, and if you wait a little, the system stabilizing approximately the same speeds. So you really don't need to worry how operating system inside virtual machines will handle a drive if you give him enough underneath. So to closing a drive, this faster speed are Hyper-V caching. I have some spare RAM, so Hyper-V also know to utilize free RAM to cache VHD files to virtual machines, and you have some performance upgrades, but they are not important at this moment. Go out from there and continue with my presentation. So, to close the disk story, there is a last question: utilize dynamic drives or not? Okay, most of you says no. And I will say yes. But how? Dynamic drives will utilize only the space that is used. And the problem is, when you have a growth, you could have fragmented on a host on a multiple chunks. And this is the same story, for example, with Exchange database, SQL database, and stuff like that. But considering things like this, for this workstation, I know that I will utilize approximately 40 gigs of space. I create dynamic drive of 128 gigs. And then, after setting up successfully virtual machine, just copy 2 Super Turbo High and Pro HD movies inside the VHD. What will I have? I have VHD file, which is 55 gigabytes. After deleting this file, VHD file will stay big, and it will have performance of a fixed size drive, but without limitation of a size. So always turn on your brain and think about it. Each technology have a good and bad side, and try to use only a good sides from each settings. And I hope that you could imagine how to do it with a SQL database or Exchange database, the same thing. You know how to do it. It is pretty simple. So you will benefit from lower space consumption. You will have exactly same performance as fixed size, and you won't be stopped when you achieve full size. Your system will continue to work. Of course, when it happens, you got to do something and adjust it. And the last thing here, network. Today, it is pretty hard to build networks. 10 gigabit networks are still pretty expensive, and gigabit networks are too slow. Not for business processes. They are slow for, let's say, people which are not thinking what they are doing. Today, you take 2 notebooks like this. This is 6-7 years old notebook, but it has solid-state drive inside. With 2 notebooks like that, I could create denial of service attack to my file server without any problems. Simply start to copy files, and whole company could not access data. So that's the problem. Problem is that client speeds are same as a server speeds, and servers should serve more clients. There are some other technologies here which are virtual machine queue and single root input-output virtualizations. Both of technologies are not work by default after setting up a server. If you want to utilize any of these technologies, you should do some small tips in the registry, reboot machine, and after that utilize it. And for single root input-output virtualization, there is a more, which means you got to go to server BIOS to enable feature, then install driver, then modify registry, reboot server, and then install supported guest operating system to utilize this high performance mode. So, let's go. How many virtual needs per physical needs? One by one is not enough, sometimes if we have situations. But usually, from my experience, if we speak about gigabit needs, 2 virtual servers will be max, 1 or 2. Of course, inside Hyper-V, we have nice technologies that we could utilize more. First, we create and utilize network teaming, or you could call it how you want. Put together more network interface cards, and this is the one of the best teamings in the world in last version of Microsoft Server, because we could mix 10 gigabits and 1 gigabit adapters, and we could mix vendors inside same team. And it is really work. For example, you have old server with Broadcom network interface cards. Take 2 of them and 1 Intel 10 gigabit card in the same team. And there is smartness inside that it will utilize 10 gig until it is not saturated up to the top. But if you don't have 10 gigabit networking, utilize teaming, take, for example, 4 cards in the same team, create virtual switch, and then on top of that, you could put 20 and something servers, because you will avoid worst case is that one server will utilize complete 1 card, but second servers will have 3 other cards, and it's really work great. And the other advice of performance tuning of virtual environment is for you utilize Hyper-V internal networking. This is on my desktop extremely fast. Now I will utilize Microsoft TCP/IP testing tool, which is simple tool for just moving data over the network, and we will, here is my receiver, and now I will go here. I will copy 10 gigs of data, which is typical server operating system backup. And it will be a boring presentation, because copying 10 gigs takes some time. But if you want and watch how it works on simple desktop, and if you watch the speeds, which is about 6 gigabytes, and on the real servers, unfortunately, I don't have it, it works about 17 gigabits internally, so use it. But what we achieve in this huge process of copy 10 gigs, a little bit more than 10 gigs, and we make complete backup of our server or deployment of a new server through internal network for 15 seconds. So, if someone of you says that you cannot back up your server, it's not true. It is really fast and efficient. So, how it should look? Place database server and application server on the same physical host, on the same virtual switch. And that's all. That's the magic. And your application will fly and won't utilize real resources on a network. If you are unsure that this process is heavy for a host, now we could do it once again, because it is really not a quick one. I just need to start receiver once again. Here we need to have to watch our host, what our host is working. And now we will start another one copy process. And watching the CPU of the host. And you see, it is notable process. But I utilized 1/32 of a physical server for super high-speed network. It is much cheaper than 10 gigabit network equipment from outside the server. And the process is finished. As you see, now we maybe achieve some better results. No, it was a little bit less data. But Yeah, that's it. So, there is a question, what if I use Hyper-V cluster?
So if you want physical host failure, have migration of one virtual machine to another host, and the internal switch will not work.
Okay. Question here was, listen and correct me. If you use Hyper-V cluster and you use internal switch, if your one host will fail, internal switch won't work. And that's true. But if you design your system that you don't use Hyper-V cluster, because for Hyper-V cluster you need storage area network which you don't want to buy and use because it is slow and expensive, then you will design your services in a way that if you lose complete physical servers and all virtual machines on them, that you don't care. How you will achieve it? For some services, it's pretty simple. DNS, DHCP, simply have two. For SQL, you will utilize database mirroring in a smaller configuration and high availability database groups or something in a bigger configurations. Exchange, simply have two servers. Application servers use network load balancing. You need to think from the beginning and then you won't have question that you ask. But if you have situation with Hyper-V cluster, you shouldn't use internal networking because it will be, or you could configure two networks and put internal network as a priority in the bindings, in advanced settings of, I could show you later in questions and answers. So there is a way how to go. Unfortunately, or luckily, nothing is work out of the box. Because if Microsoft creates server which is finishing and working out of the box, we don't have a job to do. So let it stay that way, from my opinion. So, steps in optimization. Carefully choose server components. Don't allow managers to buy servers. They don't know what they are buying, and salesmen don't know what they are selling. Configure all performance features to work. When you're deploying a server, measure performance of drives of a network to see is it according to documentation. If you miss driver or version, it could work 4 times slower than it should. So, after that, make extra effort and think and configure this subsystem. This is the slowest part and most important part because it will keep our information without current in case of some disasters. Predict future resource growth. Story about dynamic drives. Think about how much you need. Reserve it, leave it some spare, and you will be on a safe side for 3 or 4 years, which is usual lifetime of one implementation. Assign minimal acceptable resources to virtual machines, especially CPUs. It will work faster in the average than if you do it. And when you're buying equipment, try to have some spare holes to put extra when it needed. At least for memory and for drives. Maybe some slots for network cards and stuff like that. Why it's not work? So, like in life, it is important to find right balance. And now it's time to finish my presentation with maybe some of your questions, or you could contact me via email. Yeah.
Teaming can't work with SRIOV technology. For redundancy, you advise to build team, or you advise to work with SRIOV and then do Grest-Nick clusterization.
Okay. Question was, server single root input output virtualization have problems with the teaming. But now, as I read, I don't try, Intel corrected in new version of drivers. So it is supported to have two 10 gigabits adapter in a team, and that single root input output virtualization will work. I'm not sure, but in the case, if you need extreme performance, because single root input output virtualization is needed for extreme performance, then my advice is, and I will go, to have two servers, two virtual machines with the same service. One is working and one is in standby mode with NLB, with whatever technology that we use to form a cluster without shared drives. If you have only one server, then you don't need redundancy in network. Statistically, server will fail much faster, much before the network will fail. From my experience. Okay. Okay, now we could discuss this story about don't watching what are you doing after all other people go to their break. I'm aware and I will see this stuff, but I don't think that this is not for the public. So for all others, thank you for coming. Please visit site and give me some marks. Maybe I came next year, maybe no, I don't know. And thank you for coming. If you're interested in how to build different disaster recovery solutions based on Hyper-V and technologies and replication and stuff like that, I will talk it about tomorrow after the lunch. And it is a good term to have some nap also. So, thank you very much.